Here's a solubility problem where they give us the concentration of a particular ion, which is not necessarily X on its own, nor do they give us the value of KSP on its own. But they do want us to use the information they gave us to find KSP. So our goal is to calculate KSP. They give us, in this case, a concentration of silver ion in a solution of silver oxalate. Okay, one little thing. Oxalate ion is one of the less common polyatomic ions, although it is one of those that we did encounter earlier in the year, so it is worth knowing. So silver oxalate salt is what we're dealing with. Let's start by writing a good dissociation equation. Notice that there's a coefficient 2 in front of the silver that is required in order to make the equation balance. That coefficient 2 is going to have a lot of bearing on what follows. Let's make an ice table. Solids drop out. You can presume that the initial concentration of each of the ions is 0. But because of the coefficient 2 in front of silver, we're adding 2x for silver and just 1x for oxalate. So at equilibrium, in terms of x, we have a concentration of 2x for silver and 1x for oxalate. Next, before we plug in and solve, let's write the expression for KSP. Remember to take products, raise them to the power of their coefficients, and if there were a non-solid reactant, you would divide by reactants raised to the power of their coefficients. But as we'll see throughout solubility equilibrium, the lone reactant is always a solid salt, so we don't need to include that in the equilibrium expression. Okay, at equilibrium, we had found that the concentration of silver was 2x. So we'll write 2x quantity squared, don't lose the exponent, times x for the oxalate concentration. If we work out 2x quantity squared, that's 4x squared, and you still have to multiply by x. So we get the expression for KSP in terms of x equal to 4x cubed. Now, you might say, what's so hard about this? Well, read really carefully. They tell us that at equilibrium, the concentration of silver is this molarity, 2.2 times 10 to the negative fourth. Well, according to our ice table, the concentration of silver is 2x. So, 2x, the concentration of silver according to our ice table, is equal to 2.2 10 to the negative fourth. And if you're curious what the value of x would be, just divide by 2. 1.1 times 10 to the negative fourth. Take that value and plug it into the KSP expression. And then we'll get our final answer. So 4 times 1.1 10 to the negative fourth, all raised to the third power. And at this point you can pull out your calculator and crunch the numbers and you get 5.3 times 10 to the negative 12th for the value of KSP.